Hi, in this session we are going to learn a HackerRank problem titled Jesse and Cookies. Let's quickly read the question. Jesse loves cookies. He wants the sweetness of all his cookies to be greater than the value k. To do this, Jesse repeatedly mixes two cookies with least sweetness. He creates a special combined cookie with sweetness 1 into the least sweet cookie plus 2 into second least cookie. He repeats this procedure until all the cookies in his collection have a sweetness which is greater than or equal to k. You will be given the input, which is basically the sweetness of all Jesse's cookies. You need to print the number of operations required to give the cookies a sweetness greater than or equal to k. You're supposed to print -1 if this is not possible. Let's read the input which will be given. The input will be of two lines. The first line basically contains two values. The first value basically represents the number of cookies initially it will be given to you, and then the second value in the first line will be specifying the value of k, that is the minimum sweetness required for all the cookies. The second line will have n number of entries, wherein n represents the first value in the first line. This is the sweetness of all the cookies which are initially given. The output in this particular case is 2. Let's try to see how did we get this particular 2. Fine. The explanation is given here. Now let us try to understand this. Initially you have the cookies with the values 1, 2, 3, 9, 10 and 12. The minimum sweetness required for all the cookies is 7. Since all the cookies in your given list are not having a value which is greater than 7, you're supposed to take two least sweetness cookies, apply the formula and then create a new cookie. For that you'll just be using 1 into the least sweetness cookie, which is the least sweetness cookie 1, right, plus 2 into second least one, which is 2. So you take up this information, you try to perform this calculation, it is 1 into 1 plus 2 into 2, you get the result as 5, and then you try to add this new cookie into the list. So after adding up this, you have 5 cookies now with the value 3, 5, 9, 10 and 12. Observe, we have tried to add up in order so that it's quite easy for me to find out the least and the second least. Now again we'll check out that are all the cookies having a sweetness which is greater than the value of k, which is 7? The answer is no. So we need to repeat this particular operation. This is the second time we're repeating it, right? So you write 1 into the sweetness of the least one, which is 3, that is 1 into 3, plus 2 into the second least cookie. Now 2 into 5. So the result is 3 plus 10 is 13. Then you try to add that up. When you add up, you get 9, 10, 12 and 13. Now if you just observe this, we have 4 cookies and all the 4 cookies have a sweetness which is greater than 7, right? So we have fulfilled the condition, and to reach to this particular point we have to repeat the operation twice. Now let us try to take up another example out here. The number of cookies is 8 and the minimum sweetness required is 90. Now the initial sweetness of all the given cookies is 13, 47, 74, 12, 89, 74, 18 and 38. If you observe this, here the list is not sorted, whereas in the previous example the list was sorted. If it is not sorted, finding out the least and the second least is more time consuming. So let us try to sort it first. After sorting it, you get it as 12, 13, 18, 38, 47, 74, 74 and 89. Now, since all the cookies don't have a value which is greater than 90, we need to apply the formula. We write 1 into the lowest sweetness one is 12. So 1 into 12 plus 2 into the second lowest sweetness, which is 13. So we try to apply this. We get 12 plus 26, which is 38. Then we add this new cookie to the list. So new list will have 18, 38 and the remaining things like 38, 47, 74, 74 and 89. Now again, since all the cookies are not having a value which is greater than 90, so we need to repeat this. So we write 1 into 18 plus 2 into 38. We get 18 plus 76, which is 94. You try to add up to the list. So you get 38, 47, 74, 74, 89 and 94. Now again, since everything is not greater than 90, so we need to repeat. So we write 1 into 38 plus 2 into 47. So we get 38 plus 94, which is 132. Then we get this list like 74, 74, 89, 94 and 132. Then okay, again, since we have cookies which is having a sweetness less than 90, so we need to repeat this. So we write 1 into 74 plus 2 into 74. So we get 74 plus 148 is 222. Now we have 4 cookies which is sweetness 89, 94, 132 and 222. Now again we repeat this operation. 89 plus 2 into 94, you get 89 plus 188, which is 277. So now we have 3 cookies with the values 132, 222 and 277. And in order to perform this, you can just observe that we repeated this operation of 1 into least plus 2 into second least 5 times. So the answer will be 5. Let's get into implementation, guys. We'll be implementing this particular problem in C++ language. I have included the important header files which are required, that is IOStream, vector and algorithm. Now to read the input, first we'll be reading the value of n, which is the number of cookies, and k. So I'll try to read that one in a line. Like I'll just ask the user enter the number of cookies. Now once the user enters that, so we'll try to read the value, and then I'll try to ask the user enter the minimum sweetness of cookies required, right? So once the user enters this particular information, and next I need to read the sweetness of all the cookies. Fine. So I'll just ask the user enter the sweetness of cookies, right? So before I could start reading it, I need to create a data structure which can hold those values. So I'll be creating a vector of integers v, and since I already know that I require n number of elements, I'm going to reserve memory for n. This portion will reserve memory for n elements. Fine. Now I can just run a for loop starting from 0 to n. I'd like to read the input directly from the user with the help of cin and then place it in this v of I. I could also give a better name stating that it is sweetness of cookies. Fine. So once this is done, if you want to verify if the data is properly read or not, I can just try to write a display function where I'll be passing this v, and I can just receive this information here. I would like to receive this in vector of v. I don't want to make unnecessary copies. For that purpose, I'd like to write auto, which is basically nothing but an integer out here, but I've just used auto element in v. It'll automatically determine the number of elements and then repeat the loop, and in every iteration is going to get me the next element. And once I complete this printing, I would like to print a new line. Fine. I'd like to call this to verify if the input is read properly or not. Now the next step is we need to sort it. The reason why I need to sort it is the input which is given might not be sorted. Like we have taken 2 examples. In one of the examples we have seen the input was sorted, and the second example what we have seen, the input is not sorted. Now we'll try to sort these elements. The reason why we need to sort it is the input whatever is given might not be sorted, and if it is not sorted, finding out the smallest element and second smallest element will be time consuming. But it is sorted, it is much easier for me to find out the smallest element, which is the first element of the vector, and the second smallest is the second element of the vector. So I'll just write sort. I'll try to use this v.begin and v.end. This is going to do the sorting. If you want, you can verify after sorting. Okay, this is what we have it. You can verify this. Now the next thing what we need to do it is we need to repeat this loop as long as the first element of the vector is less than the value of k, right? Now here, if the first element of the vector is less than the value of k, it means that we have cookies whose value is lesser when compared to the minimum sweetness which is required. So in that case, I need to get two elements. So I'll just try to write the first one and second one. My first one will be v of 0 and the second one will be v of 1, right? Now remember, I'm just accessing this element, placing it into this variable x and y, but you need to also take care of removing it. So if you want to remove this, we can just write v dot erase and we can pass v dot begin, and you can remove two elements at one shot, but the statement what I'm writing out here, it's going to remove one element at one time and try to repeat that statement twice. Now once I get this value of x and y, I'd like to apply the formula 1 into x plus 2 into y. So now this is the sweetness of the new cookie. This is the new cookie, right? And after that I need to add this into the list. So while adding up, remember, we should not perform insert at the rear with the help of pushback. I'd like to insert in order. In order to insert in order, what we need to do is we have to start scanning and find out the correct position where we need to insert this particular element. For that, I'll start from, I'll just use an iterator. I'm using auto it equal to v dot begin. Remember, this is a C++11 construct wherein it will automatically declare this as iterator because v dot begin gives me an iterator. Fine. Now as long as it is not reached to the end, I'll try to repeat this, and what I like to do out here is I'd like to verify if the present element, if it is still lesser when compared to the new cookie, I'll say then proceed further. When I say proceed further, I'd like to say that just increment the value of it by 1 and then continue. Fine. But in case value of it is not lesser than the new cookie value, it is greater or it is equal, in that case I'd like to just come out of this loop, meaning I have reached the position where I need to insert a new element. So now you can just observe, you can come out of the loop because of two reasons. Because you have reached the end, meaning the new cookie has a value which is greater than all the existing cookie values. In that case, you will repeat all the iterations and you will come out of it. But otherwise, in case if you get a position in between, somewhere in between, wherein we need to be inserted, in that particular case, we will come out with the help of break. Now once you come out, what I'll try to do is I'd like to insert that element. To insert, I'll just write v dot insert. Now iterator is it, wherever the it is either the end or somewhere in between where we need to insert it. Fine. And then the new element what I need to pass on is new cookie. After that, after inserting it, I'd like to verify if this is inserted properly or not. And I'd like to just have a simple getChar statement to just make sure that I observe that and then I press an enter key, then I want to proceed further. For getChar, I do require this stdio.h, or I can just use any cin with a simple character. That will also be fine. I'll just try to include this. Right? Okay. Now this is the basic code what we have. Now let us try to run this and try to understand, is it behaving as per expectations or not. I have saved the file with the name jesse_cookies.cpp, and since I've used a lot of C++11 features, I need to use this option -std equal to C++11. Let me try to compile this. There's no compilation errors. Now run this. The first line we need to specify the number of cookies, which is 6, and minimum sweetness what is required is 7, right? Now the initial sweetness what we had is 1, 2, 3, then we had 9, 10 and 12. Now since you have cookies whose value is less than 7, you take up the first two elements 1 and 2, you perform these calculations, that is 1 plus 4 which is 5, and then you try to add that up. So you should get 3, 5, 9, 10, 12. In this observe, we got this 3, 5, 9, 10, 12. Okay, after that what happened is, again the first element is lesser. I'd like to take up these two, that is 1 into 3 plus 2 into 5, which is 13, and then insert out here. We got 9, 10, 12 and 13. Fine. Okay, but please do remember this is basically unsorted initially and then after it's sorting, but for this particular sample input we had sorted one, guys. Fine. Okay, clear? Simple. So 2 times we repeated, from this to this once and from this to this twice. So we need to keep track of the number of times the loop was repeated. Fine. Okay, now we'll also try to run the another input wherein we had said that we had 8 cookies and minimum required sweetness is 90, and the sweetness were 13, 47, 74, 12, 89, 74, 18 and 38. This is one of the input which is present out there but not in the sample explanations, but once you submit it you will see this is one of the inputs which is given, guys. Now you can just observe, initially it is unsorted, then we got the sorted. Now you can just see we got this 12, 13, we took up this, we calculated, and then after calculating this, what did we get? We got 38. You can just observe there were 2 38, 18, 38, 38, 47, 74, 74, 89. Then what happened out here is we took up this 18 into 1 plus 38 into 2, right? So we got this as 18 plus 76, 94. You can just see 94 is added out here. Then again we'll take up this 38 plus 47 into 2. We got this 74, 89, 94 and 132. 132 is 38 plus 94. Fine. So next step. Now you can just observe from here to here the first step, from here to your second step. Now this is my third step, fourth step, fifth step. Clear? Right, guys. Now done. Okay. Now we need to count the number of times the loop is repeated, and that will be the output. I don't need to print the intermediate results, and neither I need to print these messages. To do that, I'll come back to the code. We need to count the number of times this loop is repeated. So I'll try to create a variable out here, int c equal to 0, and every time you enter into this, the value of c should be incremented. Fine. Okay. Now once you complete this outer while loop, you need to just print the value out there with the value of c and a new line. You don't need to print intermediate values like display here, neither we require this, and we don't even require this sorting. Sorry, we do require sorting, but we don't require this displaying, guys. Fine. And then we can also comment this cout statements. We'll just try to run this and quickly observe that. So we got this 6, then 7, then we got this as 1, 2, 3, 9, 10 and 12. The expected output was 2 and we're getting it. I'd like to take this and submit in HackerRank by just commenting these statements. This is also not required. Right. Now take this code, go to HackerRank. Please make sure that you select C++14 here and then submit this particular info. Fine. Now I'd like to run this program and observe if the sample test cases are passed. Yes, sample test case, which is only one, it is passed. I'd like to submit this. And what you can observe here is some of the test cases are passed and some of the test cases are not passed. And there are two cases out here. One is it is wrong output. The other one is it is timeout. Why is it wrong output here? It was mentioned in the problem statement that if it is not possible for you to mix up the cookies and then generate new cookies, and finally we make sure that all the cookies have a value which is greater than 10, then you have to print -1, right? So we have not handled that. Like for example, we see that all the cookies have the value 1. We take up the 2's least, that is 1 into 1 plus 2 into 1, that is 1 plus 2, which is 3. Then you add up that, you get 1 and 3. Then since they also lesser, so I'll get 1 and then 3 into 2. So 1 into 1 plus 3 into 2 will be 7. Now I add that up. Remember, as of now I have only one cookie whose value is 7, and that is lesser than 10, but I cannot take up 2 cookies now because I already have only one cookie there. So in such situations you need to print -1. So this is quite easy to handle it. So what you should do out here is, before you repeat this loop, you need to verify that do we at least have 2 elements. Only then you can check out the first element is less than k or not. Otherwise you have to just come out of the loop and then print -1. So I like to verify saying that if v dot size is greater than or equal to 2 and this one is right, v of 0 is less than k, repeat this. Now since there are 2 conditions out here, what I need to do out here is I just need to check out I came out of the loop because of the failure of the first condition or the second condition. If you have come out with the failure of the first condition, you will see that v dot size will be less than 2. If that is the case, you need to print -1. Otherwise you need to print the value of c. Let's try to run the code. Fine, sample test case passed, and we'll try to submit this, and at least the ones where it was giving you a wrong output when we are supposed to get -1, at least that one is solved. And you can just observe now we are not getting wrong output, but there are some test cases which is not executing within the allotted time, right? So you can just observe that the message is terminated due to timeout. It means that your logic is not wrong, but your logic is not really efficient. So we have to look out for a more efficient problem. Right now, to perform this, we have to move out from array based implementation to a tree based implementation, because finding out the smallest element and then and second smallest element in a tree and then inserting an order in a tree is much faster when compared to a linear array. The worst time complexity of insert order in a linear array is n, whereas in a tree it is log n to base 2. We have 2 types of trees, like binary search tree, or we can think of using heap tree. Fine. Now if you want to use a heap tree, then we just need to use a data structure called as priority queue. But in case if you want to use a binary search tree, then we can basically use a multi-set. Why should we use multi-set? Is because multi-sets allows you duplicate values to be inserted, right? We have seen in the examples that we had multiple cookies the same values, but multi-set basically uses balanced binary search tree, whereas priority queue uses heap tree internally. Let's try to look into the implementation. Now let's try to use priority queue. If you want to use priority queue, you need to include the header file queue. Right now, I will not be working with a vector, so there is no need of printing the element like this. Then first reading the value of n and k is fine. Then instead of vector, we need to use priority queue, priority_q, and the type is int. Second one, I would like to specify that I would like to create a priority queue using a vector, and the third argument is something which is very important, and based on that you decide that you want to create min heap or you're going to create a max heap. So if you want to create min heap, you need to just write greater of int here, otherwise it's going to create a max heap, guys. To read the elements, we cannot read in this particular way because we cannot use indexing with the priority queue. First we'll try to read the element into a temporary variable. Once we read this in temporary variable, I have this push function wherein I can pass on this particular element. So this will take care of inserting into a priority queue. Now it is already going to sort it, so there is no need for me to sort this elements. Fine. Now here I'd like to verify if the top element, remember you cannot use array indexing, we can just check out if the top element, right, if it is lesser than k, then I need to actually try to repeat this particular operations. Now what should I do out here? I need to get the topmost element. How do I get the topmost element? I just write x equal to v dot top, but top will give me the topmost element without deleting it, so I need to remove this. I just write v dot pop. The same way I'd like to also do it for the next one, the second element. But remember, there is always a possibility that you don't have the second element, right? So we need to verify after the first deletion, if there are some elements, only then proceed further. So I'll just try to verify if v dot empty, if it is equal to true, then it means, right, there is no further cookies and you were not able to generate new values because we don't have two cookies out here. I'd like to print -1 here and I'd like to terminate the program. Since I'm writing it in the main, return 0 is same as terminating this particular program, guys. Otherwise, I'd like to take the second element, and after taking up the second element, I'd like to perform this calculation, that is new cookie equal to 1 into x plus 2 into y, right? Now it's better that you place this parenthesis out here. Even without the parenthesis, we know that multiplication has higher precedence. Once you perform this, you can add this up. To add up, we'll just write v dot push and we pass on this new cookie, right? And since we have performed this operation, I'll just try to say that C++, right? Okay, now remember, if it is not possible for you to generate the results wherein even by performing all the possibilities you will never get the cookies where all the cookies have a value which is greater or equal to k, then we anyhow come out here. So when you come down out of the loop here, it means that you have got the value of C, which is your result. So I'd like to take this particular code and submit in the HackerRank. Let me paste it here. Now let me try to compile this particular program, guys. I'll try to run this program. Sample test case passed. I'd like to also submit this one. Fine, guys, all the test cases passed here, guys, right? So the key point what we did out here is, first we tried to do it using a linear vector and we realized that it is not very efficient, so we had to move into a priority queue which internally uses a heap tree, right? Now tree data structure is much more efficient when compared to your linear one, like finding out the smallest and finding out the second smallest, or you can say inserting in order. Fine. We could also do the same problem using multiset also here. Thank you.